Okay, my name is S.S. Rajan. I BE Mechanical Engineering from Bombay University. Presently working as Associate Professor in the Department of Marine Engineering. I am assigned the topics for marine internal combustion engines and marine auxiliary engines for the third year students. Okay, I begin with lecture mainly dealing with the components of a diesel engine. A diesel engine, as you know, is a compression ignition engine. The theory is based on a quasi-static process. As I listed here, you have a piston. Here. The piston is moving, or rather reciprocating and contributing to the work cycle. In case of a two-stroke engine, you have one firing cycle every one revolution, whereas in the four-stroke engine, you have one firing stroke for every two revolutions. I repeat, the firing cycle in two-stroke engine, one firing cycle for every revolution, and in four-stroke engine, you have one firing cycle for every two revolutions. Naturally, you will expect the two-stroke engine to produce more power. Okay, but that besides, what is this two-stroke and four-stroke? What does it imply? It implies that the thermodynamic cycle, that is your compression, ignition, expansion and exhaustion, is going to take place or completed in one revolution for a Stokes cycle, whereas the same thing is accomplished in two revolutions for a four-stroke cycle. Naturally, because you have a dedicated induction cycle and a exhaust cycle for a four-stroke engine, the scavenging process is very, very effective in the case of a four-stroke engine. Now, the choice between four-stroke engine, two-stroke engine is, if you have a headroom, no restriction on the headroom in the engine room for the ship, then you can go for a four-stroke engine. Whereas if you have restriction on headroom, then you have to go for a four-stroke engine for a ship. If you have no restriction, then you can go for a two-stroke engine, where the two-stroke engines generally very, very powerful. They are about having a stroke to bore ratio of 1:3. That means bore is 1, then stroke length will be 3 times the bore size. So naturally, we are going to transport cargo in the range of lakhs and lakhs of tons of cargo, for which you need a very powerful engine which can develop a power of maybe about 50,000 kilowatt and around that. Okay. So, but besides that, now we have to go to the elementary knowledge about the engine. As you can see on the picture here, we have the main engine of a two-stroke main engine. The manufacturer of this engine is a Sulzer engine, Wärtsilä Sulzer engine, and now as you can see, I have put a view of a two-stroke engine which is belongs to it can be a main BMW engine or it can be a Sulzer engine. As you can see, we start from the bottom. As you can see here, you start from the bed plate, then you have A-frame, and then you have the cylinder block, which is also called entablature. Then these parts are called the stationary part of the engine, which is equivalent to a human being. As a human being, you have a cylinder head, two arms, a skeletal structure on the feet. The similar way, you have a bed plate which is mounted on the tank top, and this is a bed plate, and this is A-frame, this is A-frame, that is skeletal structure, and above that you have the cylinder block or the entablature. Inside we have the cylinder liner in which your piston is reciprocating. As you can see here, you can see a piston here with a long rod, and that is reciprocating part. It is reciprocating in the cylinder liner. This is the cylinder liner. As you can see, this is cylinder liner. Now, for any engine to work, you need a combustion chamber for firing to take place. So, as you can see here, the cylinder liner and the cylinder space is closed by a cylinder head. Closed by a cylinder head. You can see the cylinder head is closing the combustion chamber. So, one part of the combustion chamber is underside of the cylinder head, and the other part is the cylinder liner walls, and the third part is the top of the piston, which is called the piston crown. So, piston crown is a movable part, whereas the cylinder liner and the cylinder head, they are stationary part. So, in the compression take place, rather the piston is at the top dead center, where the acceleration is 0, velocity is 0, and acceleration is maximum, and retardation is maximum. So, piston comes to a total halt at the top, and the compression pressure is around about 100 bar. So, that is quite large enough for heating the air, and at the same time it is so timed that the fuel injectors are injecting fuel, fuel injectors are injecting the fuel, and the ignition take place, and the pressure is built up to about pressure of 130-150 bar, and the piston start moving, contributing to the working cycle of the engine. So, that is the basics of the engine, but today we will be describing each part of the engine. So, let us start from the beginning, from the base. Any engine should require a foundation, This view, what you see here, is a two-stroke engine, cross-sectional diagram, a very large engine. The next slide I am going to show you, is what you see here is a four-stroke engine cross-sectional diagram. What is the difference between this picture and this picture? What is the difference? As you can see here, the two-stroke engine, the two-stroke engine piston is having very long rod. It is passing through a crosshead and then through the connecting rod. I mean, piston is not directly connected to the connecting rod. That is the difference. Whereas you see the next slide here, here you see the piston. The piston is having a very long skirt and is connected to the connecting rod directly. Connected to the connecting rod directly. Now, in both the cases, connecting rod is a common link that is going to transform the reciprocating motion of the piston to a rotary motion in the crankshaft. Where is the crankshaft here? This is the crankshaft, and you need a radial distance that is offered by this throw called the crank throw. The connecting rod is connected to the crank pin, and the reciprocating motion is giving angularity to the connecting rod, and that is going to contribute your torsional motion to the crankshaft, and you are going to get rotary motion that is connected. Crankshaft is directly connected to the propeller shaft, and propeller shaft is causing the ship to move in the ahead direction or the astern direction, depending on which direction this crankshaft is going to rotate. Okay. Now, let us see the parts of the four-stroke engine. We start with the bed plate. We start with the bed plate here. You can see here, this is the bed plate, and this bed plate is mounted onto the tank top, bolted onto the tank top. Now, here one essential difference here is the bed plate is having a particular shape like this called, this shape is called a trestle type bed plate, trestle type bed plate. And look at the other picture here. Here the bed plate is box type structure. It can be mounted directly to the tank top, So that is the difference between a box type bed plate and the trestle type bed plate here. Okay, that is different. Okay, now let us concentrate on the bed plate. How it is, what are the details about the bed plate. The bed plate is nothing but it is a foundation. Every equipment shall be requiring a foundation. So here in case of diesel engine, it is the bed plate that is the foundation for the engine. The bed plate is supported by its position onto the tank top or the double bottom tank, inner skin of the ship. Okay. Bed plate usually is made up of cast steel. Modern bed plates are made up of cast steel. Okay. As you can see here, the bed plate, what is the requirement of the bed plate? It should not be too rigid. It should have some amount of flexibility. Why you need some flexibility? Because the ship is moving in the water. The water you don't expect to be very steady. Depending on the sea condition, you may have a trough and a crest. So accordingly, the bed plate, if it sits on a crest or a trough, then it is subjected to a bending moment. So the bed plate structure should be having some amount of flexibility. So at the same time, we should also have some rigidity to withstand the gas forces of the piston when it is firing. Basically, bed plate consists of two longitudinal girders which run the entire length of the engine. Connecting these longitudinal girders are the transverse girder, which are positioned between each crank throw. Okay, here is a elementary sketch of a bed plate. Now what you see here, the single line on either side, that is called the longitudinal girder. So this is the structure of the bed plate that is going to be having some amount of flexibility. Because we are talking about flexibility, the material of this bed plate, material of the longitudinal girder, which is box shape, should be mild steel, low carbon steel. It will have some amount of ductility and flexibility. Whereas these two longitudinal girders, they are connected across by a transverse girder. This is called the transverse girders. The transverse girder should be having some amount of rigidity. Why rigidity is required? Because it is subjected to, along the central line, it is subjected to gas forces. So here you see a pocket here, a semicircular pocket where the crankshaft is going to sit. What is crankshaft? Crankshaft is the rotating medium that is going to transform the reciprocating motion through connecting rod into a rotary motion. So this pocket is called the bearing pocket because crankshaft as it's supported, it is supported under the main bearing supported sitting on these transverse girders. Main bearing supported on the transverse girder. As you can see, the space between these two transverse girders we can qualify as one particular unit. In a multi-cylinder engine, this is one unit of a diesel engine. Okay. Now, I just go back to the previous slide. Let us see at the requirement of the bed plates. Okay, what is the forces that the bed plate is subject to? Firing load, the firing load from the cylinders. Then the angularity connecting rod is going to contribute to some thrust forces. So thrust forces is taken by the guide faces. As I say, in a two-stroke engine, the piston rod is very long. It is connected to the crosshead. Crosshead is moving in the crosshead guide, and crosshead guide supported in the A-frame. There are unbalanced inertia forces in the running gear. As he even studied the mechanics of machine, that the rotary motion can be 100% balanced, whereas the reciprocating masses, inertial forces reciprocating masses cannot be balanced 100%. Normally the designer will leave about 1/3 of the inertia forces unbalanced. So that's naturally the thrust that is involved, it is taken up by the guide faces, So the propeller is subjected to torque, which is part of the crankshaft, and hull deflections due to hogging and sagging. This is additional forces that the crankshaft bed plate is subjected to. What is hogging and sagging? You know that when the piston, when the ship structure is bending downwards, deflection is downwards, it is called sagging. The deflection is upward, then it is called the hogging. Okay. So in addition, there are vibration due to torque variation, because propeller is not going to move uniformly, because if you have many cylinders, then the turning moment of the engine will be uniform. But if you have only very less number of cylinders, then it can be variation in torque. So you can have some shock loading because of the propeller is not moving in a uniform water. Then the firing load is going to cause thermal stresses due to atmospheric and lubricating oil temperature changes. Okay. And bed plate is also subject to inertia and gyroscopic forces due to ship movement in heavy seas. Okay. In addition to these forces, the bed plate also has to form an oil tight chamber for accommodating the lubricating oil, for lubricating the bearings. Okay. And also is supposed to provide a housing for the thrust bearing. See, the propeller blades, they are not, they are having some amount of rake angle and a skeeving angle, which is going to provide a linear axial thrust. So that thrust has to be taken up, accommodated in the thrust bearing, which is part of the crankcase, which is part of the bed plate. Okay. So having provided all the above, bed plate should be also small and light to keep the overall size and mass of the engine to a minimum. Please, after having provided all the rigidity and flexibility, the bed plate also should be designed in such a way that they are light enough and at the same time have very small mass, so that the moment mass inertia will be much less. Bed plates consist of two longitudinal girders connected by two transverse girders. The space between two transverse girders forming one unit for the cylinder. Okay. And the girders are supporting the main bearing saddle. This is called main bearing saddle, on which the one half of the main bearing is resting. On top of the main bearing you have the crankshaft. This is the center line of the crankshaft connected to the propeller. Okay. So this is how a modern bed plate will look like. As you can see here, the ship engineers, they are assembling the bed plate and checking the alignment, and you can see the transverse girders very clearly, and this is the saddle pocket for the main bearing, and these are two side girders. This is one unit, second unit, third unit, fourth unit, and so on. Okay. So what you see here is the examination sketch for the students, a picture of the bed plate. Everything is clearly mentioned here. Main bearing saddle, these are stiffeners, contributing strength of the box type bed plate. This is a continuous girder, this is a longitudinal girder, and this is the transverse girder. This is the longitudinal girder, part of the longitudinal girder. So the whole thing is a box type shape. So here, this slide, again the bed plate is shown here. As you can see here, you can see a green color bolt, and you can see the main bearing, and this is the transverse girder of the box type bed plate. Now what is the significance of this bolt, which is called tie rod bolt? Now the function of this tie rod is to connect the cylinder head, the uppermost part of the engine structure, through the A-frame to the bed plate, and bed plate in turn is connected to the ship's tank top. So this tie rod is always under tension, and keeps the cylinder head and the A-frame and the cylinder block, A-frame and the bed plate under compression. Now in this picture, as you can see here, the bed plate longitudinal girder is bolted to the tank top, bolted to the ship's tank top. Now what you see here in this small X-shaped thing, they are called the chocks. They are called the chocks, CHOCKS. So these chocks, generally in modern ship, they are made from resinous material. Olden days, they used to be made up of cast iron. What is the purpose of these chocks here? Now see, what is the function of the main engine? To give propulsive power to the propeller shaft. Now, naturally, the center line of the crankshaft on the center line of the propeller shaft should be on the same center line. Okay, so naturally, we may have to adjust the height of the engine up and down. Bed plate will move up and down by hydraulic jacks, so that you create a space for perfect alignment, and the space that is created is made up by the cast iron chocks or resinous chocks. Okay. In addition to this, we are taking care of the vertical height of the engine. At the same time, the ship is in motion, the engine is running, the main engine should not move sideways or along the axial direction because of the propeller axial thrust. So therefore, the freedom of movement sideways is arrested by these chocks, side chocks. They are called side chocks. These bottom chocks, they are called the main chocks, which is for aligning the crankshaft with the center line of the propeller shaft. Okay. Now, as you can see, the tank top on the bed plate is bolted through the chocks, and this nut on the bed plate is accessible to you, whereas the bottom nut will be accessible to you only by entry into this double bottom tank, and this empty space is called cofferdam. The empty space is called cofferdam. The space below the bed plate forms a sump tank for holding the lube oil, for lubricating all these bearings and cooling the piston, etc. Okay. Let us take a look at what are the material that is used for the bed plate. So bed plates are usually fabricated from mild steel. What is the purpose of mild steel? Mild steel is low carbon steel. It contributes to very high strength. At the same time, it will have some ductility and flexibility, which is one of the requirements for the longitudinal girder. So it also mild steel, a welded type mild steel, 25% less weight compared to a cast iron type, and it can be easily molded. Mild steel can be easily molded, or forging is very amenable to the forging process. So most of the bed plate, they are forged as a single unit and connected by welding. But unfortunately, the mild steel has got a very low vibration damping characteristic. Hence, it is liable to crack on the welds. So this is one of the key defects we will find on the bed plate if it is not properly, if the forces are not properly balanced and taken care of. Okay. Whoever does the welding of the bed plate, transverse girder to the longitudinal girder, should be expert, so that the welding should be proper. At the same time, after completion of the welding joint should be properly stress relieved. Okay, we talked about the requirement for the bed plate, in which we said that the longitudinal girder should be having some amount of flexibility and strength. So therefore, you will go for a composite type of construction of the bed plate, where the longitudinal girder is made up of mild steel or low carbon steel, whereas the gas forces should be accommodated by the bed plate. So naturally, the transverse girder, which is bearing the brunt of the gas forces, and finally transmit the longitudinal girder, and from the longitudinal girder to the ship structure. So this transverse girder should be having very high strength and at the same time rigid enough. So therefore, generally the transverse girder, they are made from a cast steel with some addition of some molybdenum and other alloying elements, which contributes to the enhanced strength of the transverse girder. So Cast steel welds are more stronger than the mild steel. Any size can be manufactured. Usual defects that occurs on the bed plates are cracks around the weld, oil leakages, loose chocks, loose A-frames. One of the important thing to note down here for the student point of view and the engineering point of view is that the bed plate should never be painted. Bed plate should never be painted because the lube oil is sloshing in the bed plate and any paint flakes can cause damage to the main bearings and subsequent cumulative damage to other bearings also. So, as you see on the slide, these are the common faults that you find in the bed plate: cracks, oil leaks, loose chocks, loose A-frame. Chocks is for aligning the crankshaft to the tail shaft or the propeller shaft. Okay. A-frame is the one which is the structure of the engine which is mounted on top of the bed plate. Okay, where does this crack occur on the bed plate? Usually under the bearing pockets on a fabricated mild steel bed plates, radially around the tie bolt and the frame bolt holes, between the longitudinal transverse girders, around the lightning holes and at the base of the serrated seating for main bearing keeps. Okay. So, this is a picture of that, the defects. As you can see here, this is the lightning holes. You can see the cracks. These are the cracks and these are the stiffener that is welded to the longitudinal girder. So, you can find at this weld some cracks here, and this is the bearing saddle. Below the bearing saddle, you will find the crack across the transverse girders. These are the cracks, these are the cracks, these are the cracks. Okay. So, this is a common defect, and one of the advantage of this fabricated mild steel bed plate is that it can easily repaired. It can be easily repaired after cleaning by welding. Only thing, welders should be have high quality skill. Should have possess a high quality skill. That is the most important thing. Okay. What could be the reason for the bed plate cracking? Some of the reasons which is highlighted here. It can cause could be because of the worn down bearings. Therefore, some bearings are overloaded, some bearings are underloaded. So, there is generally a tendency for crankshaft to bend. Second thing is the tie bolt which is connecting the bed plate to the A-frame and the A-frame to the cylinder block or entablature is loose. Tie bolts are loose. And engine units are not balanced. So, therefore, you may have some vibration, either engine induced vibration or the propeller induced vibration. The fourth point is that the skill of the welding itself may be poor quality welding, or welding may be good but it was not properly relieved of the residual stress that is left after welding. And there are some discontinuities of the structure where there are change in cross sections, then all these welds have some stress risers. Coarse welds should be ground properly, otherwise it can be a point of discontinuity and provide a stress raising and contribute to the crack of the weld. We have completed the bed plate. We have given a fair, I think by now you will have some fair idea what is the bed plate. Bed plate is the main foundation on which the engine is resting. So, now we move on to the next part, which is the moving part, crankshaft. The bed plate is supporting the crankshaft, and crankshaft is aligned to the propeller shaft, and alignment is done by the chocks. Alignment taken by the chocks. Okay. Now, let us take a look at some of the important points in the crankshaft. What is the function? To convert the linear motion of the piston to rotary motion of the output shaft. Second one, it consists of journals, crank webs and crank pin. Remember, crank pin is part of the connecting rod. Lower end of the connecting rod is called the crank pin bearing, and the arm of the crankshaft is called the crank throw. The distance from the center line of the main journal to the center line of the crank pin is equal to the half the engine stroke. Usually, the long stroke engine, this ratio will be 3:1. Okay. The counterweights. What are the counterweights? Now, any masses which is rotating or reciprocating will have unbalanced forces, will have unbalanced forces. So therefore, in order to balance the rotary masses, we will be having counterweights. Counterweights are added to the web. Counterweights are added to the web opposite the crankpin, which improves the balancing of engine and relieves the load on the main bearing. Okay. Now this is the main function, mainly to transform the linear motion of the piston into reciprocating motion, into a rotary motion, and then the part of the crankshaft is rotating within the crank journals and crank webs and crank pin or the other parts of the crankshaft, and the crank throw is the distance from the crank pin to the crank journal, which is the throw distance or the radial distance, which is contributing the torque of the engine. Okay. And counterweights are provided on the opposite side of the crank pin to counter the unbalanced rotary masses, because the rotation of the crankshaft is going to induce a centrifugal force. So this centrifugal force has to be countered by this counterweight. Okay, so that is the reason why counterweights are provided on the crankshaft opposite to the crank pin side. Now, let us go into the very types of crankshaft. Modern crankshaft, they are all semi-built type. We will concentrate more on semi-built type rather than on the other type, fully built and the solid forged types, because both fully built as well as solid forged crankshaft, they are not there anymore. Even though if it is there, very few in between, they are going for this fully built and solid forged crankshafts. Okay. Now I have put in a picture of a crankshaft. As you can see, that this is the center line of the crankshaft, and this is where the main bearing is going to sit, and this is the crank throw or the crank web, and this is the crank pin on which the connecting rod is connected. This is again crank throw or crank web, again main journal, crank pin, crank throw, main journal, the crank pin, crank web, and the main journal. And as you can see, there are holes here provided onto the journals, that is for conveying the lubricating oil for the lubricating the main bearings, and also to send oil for cooling the piston through the connecting rod. Okay. So now the end of the crankshaft, we have a flange here. And this flange is bolted to either the thrust shaft or to the flywheel. Okay. If it is a small engine, we can have a single forged crankshaft. But if we have a very large engine, it is not possible to forge a single crankshaft which the length is maybe 15-20 meters, very long engine. So therefore, in such a case, what they do, they make the crankshaft in a semi-built type, where the crank web and the crank pin, they are forged from a single steel ingot piece, and then journal is made separately, and then the hole is drilled into the crank web at the crank lower end, and the crank web is expanded to a white heat, and the journal is pushed in and allowed to cool. So once it is cooled, the crank web is going to hold the crank journal very tightly. Now this string fit allowance that they provided is about 1/570 to 1/620. That is 1/570 of the diameter of the crank journal. Okay, again, the webs are heated up on the crank pin journal fitted with the holes. As the webs cool down, the diameter of the bored holes would try and shrink back to the original size. In doing so, the crank pins and journal would be gripped tightly. Today, most of the crankshaft, they are never keyed. Their parts are not keyed at all. They are all shrunk fit. So, after shrink fitting, you must make a reference mark so that next inspection or whenever you do a frequent inspection, this reference point should be observed very, very closely, so that there is no slippage of the crank web around the crank journal. Very, very important that once a slippage takes place, the entire wall timing diagram of the engine will be affected. Engine will be affected because from the crankshaft, the drive is taken to the camshaft. Camshaft is having all the timing gears, all the timing gears, mostly the cams for operating the various other moving parts, which we are not discussing in this lecture. That will be covered in a separate lecture. So we just discussed that how the semi-built crankshaft is built, that is the crank web and the crank pin is made from a single forging steel ingot. For each unit it is made separately, and then on the crank web 2 holes are made and the journal is shrunk fed. What is the shrink fit allowance that is provided? It is 1/570 and this is a range 1/570 to 1/660 of the diameter of the journal. The shrink fit allowance is between 1/570 and if we exceed this or go beyond this, what is going to happen? Around the shrink fit hole or the crank web is going to have a cracks. Cracks will develop, and very easily the next thing that is going to occur is the crank web is going to slip around the crank journal and entire wall timing diagram is going to be out, and engines will be very unbalanced and lot of vibration is going to be induced. Advantage of this method is construction is that by making 2 webs and crank pin from a single forging, the grain flow in the steel follows the web around in the crank pin and back down the other web. That means that the continuity of the line of the forging line. Forging line should be continuous flow of the grains. So as you can see here semi-built crankshaft, this web and the crank pin and the web is a single piece. After this forged with a single steel ingot, holes are drilled here and holes are drilled here, holes are drilled here and holes are drilled here, and this diameter of the throw is smaller compared to the journal diameter. This is a journal or crank journal. This diameter is bigger than the diameter of the crank web. So that is, it is how small it is? By 1/570 to 1/660. So that is what is contributing to the shrink fit allowance. Okay, because the crank pin and webs are single forging, the webs can be reduced in thickness. So therefore, a hole is made sometimes across the crank pin. You can see a small hole, that is for lightening reducing the weight of the crankshaft. Okay. So if the shrinkage allowance is beyond the limits, then you can have cracks developing here on the crank web, and then the crank journal is liable to slip. Okay, this all welded crankshaft has been there, but percentage of welded crankshaft made is very, very less, because the reason is that it needs very high skill at the same time is very, very expensive. It's proved to very, very expensive. Material that is going to make these welds are very, very expensive. So therefore, even though the performance is good, they are not very, very popular because of the cost factor. Okay, for smaller engines is okay, but for a very large engines, it is not suitable. All welded crankshaft will look like, where in all welded crankshaft, each part journal is welded to the crank web is separate, journal is separate, and the crank pin is separate. So there are several weldings involved in making up the journal and the crank web and the crank pin. Okay, and then finally they are all welded together to form a single crankshaft of multi units. So apart from the crankshaft manufacturing, most important part is that any moving parts has to be lubricated. So the crankshaft holes will have to be drilled for creating a path for the lube oil. So as you can see here, the holes are drilled in the crank journal and the crank pin to convey, and across the crank web to convey the lube oil. Lube oil is fed here, and from where it is transported to the journal. From the journal it goes through the connecting rod, which is connected to this portion of the crank pin. So I think with this we have a fair idea about the the crankshaft and the bed plate. So the next lecture, whenever we find time, I will try to cover up the rest of the parts, of the moving parts and the stationary parts. Thank you very much. So today, in summary, what we discussed about the 2-stroke engine, 4-stroke engine, and then we also discussed the skeletal structure of any part, whether it be a human body or the engine part, should have some skeletal structure. On skeletal structure, it needs a foundation. Like legs are the foundation for the human being, similarly the bed plate is the foundation for the engine. On top of the bed plate, you have this other skeletal structure like your legs and your chest cavity, and then the cylinder head and neck and etc. So same way, the engine also will have a cylinder head, internal parts like lungs. We have for human body. Similar to lungs, we have a piston for generating power. Similarly, you have where the combustion chamber, you have a combustion chamber for the engine. Same way, human body is having combustion chamber. Where is the combustion chamber of the human body? It is the stomach, where you are eating food that is producing a chemical energy and giving the energy for your motion. Okay, thank you very much. I think I have done some justice. Thank you.